know, what made you get interested in viruses? Like, how did it all start?
So that's a big question, and that's a long time ago. So I think probably the most important thing for me when I started my career as a trained scientist was that I always wanted to apply all of my knowledge back into solving problems, particularly disease problems. And viruses cause many, many problems, as we know. COVID-19, as it's gone through as a pandemic now, but I started off in the world of influenza. And so flu had no solutions. We had a vaccine strategy, but when a pandemic came along, flu had no solutions in terms of drugs. So unfortunately, the vaccines for a pandemic wouldn't work until you had a specific new pandemic vaccine. So drugs had to be the ultimate goal to say, we need something that can save lives. And so for me, some 25, 30 years ago now, I've become very interested in applying my knowledge and my training to creating drugs that treat viral infections. And so influenza was the starting point. And of course, now as time's marched on, since we solved that problem, we got a drug for flu to market, and that saved many, many lives in pandemics particularly, but also in regular epidemics. Of course, now there are many viruses that have come through, particularly viruses that affect the lungs and upper airways as well in the elderly population, like SARS-CoV-2, COVID-19. Therefore, it's predominantly a disease of the elderly, and unfortunately, without either a therapeutic to lessen the mortality, loss of life, you see a lot of people die, and that's what exactly happens. So that's why my focus has always been, let me try to solve problems that have no solutions.
Yeah. Well, and how did it feel firstly with the flu solution? Like when you finally got it, how did you know that this is it?
So we call that the eureka moment, right? That you go, aha. And so I have to say that after involving myself in the project for 3 years, we got to a point where we said, we've got a compound that is really a drug-like molecule that is really potent and it should work. Why can't it work? And lo and behold, it did. Wow. So the eureka moment came very early on in that project. Yeah. The issue always is that then, of course, having that fundamental eureka moment, saying, I think we've got it, to actually prove you've got it, takes another 8 to 10 years.
Really?
And so that's always the long path, unfortunately, for drug discovery, because you have to go through safety trials, the whole kit and caboodle, to make sure that the drug is going to be as useful and efficacious as you believe it is.
Yeah, amazing. So what exactly are you working on now in particular?
So we have broadened our horizon, so we still work very much on discovering new antiviral drugs. So some of the diseases that people would understand is croup in kids, for example, that leaves a debilitating barking cough and sometimes hospitalizes infants. It also hospitalizes elderly. It certainly kills a lot of immunocompromised people, people going through chemotherapy, for example, unfortunately. And again, like flu, currently there is no drug and no vaccine to treat or prevent parainfluenza infection. So I'm pleased to say that we now have a drug candidate that's marching through trials right now that we hope will be the first drug to market to treat and prevent parainfluenza infection. Wow. So that would be a big deal for us to get the next respiratory virus. We work pure, and so we work on other respiratory viruses. Another one is called human metapneumovirus. It's like flu, it's like paraflu, it's seasonal. It comes around typically every winter. It's here right now with us. And as is RSV, respiratory syncytial virus, another virus that we work on, all of these viruses have no solutions at the moment.
Yeah.
And so we really focus on being clinical benefit and saving lives, tackling those particular viruses. Of course, we're also looking at other diseases like cancers.
Yes, that was my next question.
Yeah, so cancers are, of course, remain a major problem. All types of cancers typically remain a major problem. And you'd think after 60 years, 80 years of research across the world, we'd find some magic bullets. And unfortunately, whilst advances have been made, we haven't found yet magic bullets.
Is there a correlation between viruses and cancers?
Interestingly enough, it's a very interesting question. There is for some cancers. So, for example, we know that human papillomavirus can cause cervical cancer, and the wonderful work of Ian Fraser and others led to a vaccine that actually tackles that particular virus, which prevents then cervical cancer actually occurring. And so that's a vaccination program that's been rolled out worldwide. And there are indeed other viruses. So hepatitis virus can be linked to liver cancer, amongst others. So there's a lot of viruses that are directly connected to certain types of cancers. I would suspect, though, that the majority of cancers are not in virus in origin. They actually appear as a consequence of, unfortunately, not so good genetics, or indeed perhaps exposures to other environmental factors like lung cancers, for example, people smoking, and if they breathe in asbestos and things like that. So there's a lot of other factors that also come into play. So we're very interested in seeing what we can do to bring our research from our direction into solving and providing solutions for cancers of one type or another. And so that's exactly what we do. We are cracking the code that we're interested in to say, well, can we look at new biomarkers for different cancers, but also can we find new therapeutics based on those understandings.
Oh, it's amazing. It's a big job, Mark. It's a big job.
It's a big job, and you know, and I'm sure that the public understand that it takes years to actually bring this information to light, and therefore it takes decades to actually find solutions. And so we firmly believe that we will find solutions to all of these cancers at the end of the day. The fact of life is that, I just keep with cancer, is that unfortunately we are all destined to have cancers of one type or another. It's called the aging process. And so our immune system just doesn't cope as well as it did when we were young and fit. And so cancer cells escape and unfortunately spread. So it's a natural consequence of life. In some ways, we just handle it better.
We're living longer too. So.
We're living a lot longer, and the prediction is that we will continue to increase our lifespan due to the wonderful outcomes in medical research, which is great. Of course, we need to take care of other things if humans live longer. The planet being a very good one. And so there's always a cost-benefit ratio in improving lifespan as well.
Well, thank you very much.
You're welcome.
It's been great.
You're welcome.
So much information, and hopefully we'll find solutions in the future.
Well, I hope so too. Well, it's essential that we do.
Yes, absolutely.